Welcome to lesson 224, using percents. So today we're going to talk about why we've been converting percents and what we've been doing with all of them and how we can actually use them. So instead of diving right into the word problems, I want you to understand how to actually solve the problems. So if I look at this problem, 45% of 20. 45%, again, is not a number. It's a percent, but we can't use percents in mathematical operations. It's an idea. Okay, it tells you that out of 100, you would have gotten 45 of something. So what we do is, since a percent means out of 100, we can do one of two things. We can multiply or use a proportion. Of tells us that we're going to multiply, and 20 is how many we have. Right? So in this case, I want 45% of something, so I can multiply, I can make an equation, and I know that I need my percent as a decimal because I can't have it as a percent, times the number that I have, and that's going to give me the numerical value of my percentage. So it's going to tell me what is 45% of 20, because I know 45% of 100 means that if there's 100 of something, what is 45% of it? Well, since 45% means per 100, it means that there are 45. But since the number isn't 100, since it's 20, we have to set it up differently. So you can set it up as an equation, or you can set it up as a proportion. You would put your percent over 100, so instead of turning it into a decimal, we turn it into a fraction. And then we would set it equal to the number that I have, so the total over x. So in this case, if I was doing 45% of 100, I could do 45 hundredths times 100, which is going to give me 45. Or I can do 45 over 100. Okay, so that's my percentage as a fraction. And then I set up my other fraction so I can make it proportional and say, all right, well, I have, in this case, we're working with 100 because I'm doing the 100 example. And I want to know how much that is. So 45 times 100 equals 4,500. And I know then that 100 times x has to equal 4,500. And I can divide both sides by 100. And I find that x has to equal 45. Right, so this is just an example with the use of 100. When we change the 100 to a different number, we're going to get different answers. So in this case, if we're doing 45% of 20, I can change to a proportion, so I know that 45% has to change to a fraction in order to use my proportion. And then on the bottom is always what I have total, so 20. And on the top is the number that I'm looking for. Or if I set it up as an equation, I can do my total, which in this case is 20, my decimal as a percent, so 45% is 45 hundredths, and then that is also going to give me my answer. So you can set it up in two different ways. Now this is just for a problem of what is 45% of 20 is what. So this is 45% of your whole equals what part. Right, so if we move along here, we're looking for something different this time. So I want to show you that if you set this up, you have your percent over 100 set equal to a part over a whole. Or you have your total, so your whole group, times your percent, but as a decimal, is equal to the part. So you have to figure out what each of these pieces are. In this case, we don't have a percent, so the percent would have to be the x, but the percent always has to go over 100. And then 2,000 is my whole because it says what percent of 2,000 is 204. So 204 is the part, and 2,000 is the whole group. So 2,000, 204. I can also set it up by saying 2,000, which is my total or my whole, times my percent, which I don't know, is equal to my part, which I know is 204. To solve this, okay, so I cross multiply, I do 100 times 204, and that is going to be 20,400. So now I know that x times 2,000 has to equal the 20,400. To solve, I need to divide both sides by 200,000 because I want to get rid of 2,000 and get the x by itself. And what I do to one side, I have to do to the other. Okay, so now just to make this go a little faster, I'm going to use the calculator. 20,400, which I got by doing 204 times 1 is 204. Add the 2 zeros to the end. Now I divide it by 2,000. See, so x has to equal 10 and 2/10. So now it's 10 and 2/10 over 100 equals 204 over 2,000. I know that I want to turn this into a percent, and whenever I have my number over 100, I can just write it as a percent, so my answer is 10 and 2/10%. So now the answer that I have here should match the answer that I have here. So in this case, I want, again, to get rid of the 2,000. So if you notice, you're actually doing the same thing, you're just taking out the multiplying part. So I divide both sides by 2,000. Now my answer is going to look a little bit different this time because it's going to come out in the form of a decimal instead of a fraction. So now I'm doing 204 divided by 2,000, and I get 102 thousandths. But this is a decimal, and I know to go from a decimal to a percent, I have to move my decimal 2 places to the right because I want my answer, so this is my answer as a decimal, and I want it as a percent, so I have to change it from a decimal to a percent, and I get x is equal to 10 and 2/10%. So I'd like you to take a second, read this problem carefully, put your numbers in where they belong. I would also make sure to have this written up in your notes somewhere so that way you have it to reference so you know which piece of the proportion or the equation goes where. You can even turn this into a multiplication sign that's an asterisk, so it's easier. And when you come back, we'll check your answer. All right, so in this case, what percent of 75, so of 75 means that it's our whole number, is 10%? Well, now that's worded incorrectly. So it should say 10% of 75 is what? Sorry about that. So if that confused you and you want to pause again to try and look at that, that's fine. Otherwise, we'll continue here. So is what means we're looking for the part because we have the whole, so we're looking for the part. And we have the percentage that we're going to write as a fraction. As an equation, 75 was our total. Our decimal is 10 hundredths, and our part is unknown. So here I can actually just do the math. 75 times 10 hundredths. Okay, so this is actually kind of like dividing, so it's going to end up moving the decimal one place to the left. So I get 7.5 is equal to x. Now, because I wasn't finding the percent part, I don't need to change it. So 7.5 is my answer. So let's double check over here. If I do 10 times 75, I get 750. So I know that x times 100 has to equal 750. So I have to divide both sides by 100. And I know x is equal to, Get rid of those zeros. 75 divided by 10 means I move my decimal one place to the left. 7.5. All right, so all these problems are set up a different way. Now, they are word problems, however, they're not lengthy word problems. They're not word problems that are actual real world situations. I just wanted to get your feet wet with this. So what I'd like you to do is for the first couple of them, I will help you out with them. And actually, since we've done each one of these, I want to just work on this one, and then you'll have the last 5 to do on your own. So 20 is 75% of what? So I have my percentage that I can change to a fraction. 20 is 75% of what? Well, of what means we don't know our whole, but we know our part is 20. So we know that this is a smaller part of a bigger part that we don't know. The other way we can set it up is to say we don't know the total, but we're going to multiply it by the decimal, and it should equal 20. So now to solve this, I do 100 times 20. 1 times 2 is 2, and I have 1, 2, 3 zeros, so 2,000. So I know that x times 75 has to equal 2,000. To solve, I have to divide both sides by 75. Okay, so I can grab my tools, get that calculator back out here. 2,000 divided by 75 is equal to, so x is equal to 26 and 6/10 repeating. So now I should get the same thing over here. So I have to divide by 75 hundredths, divide by 75 hundredths. 20 divided by 75 hundredths gets me x equals 26 and 6/10 repeating. I would like you to try doing these both ways. If you like one way better than the other, that's absolutely fine to use that way. But I want you to realize that you're actually doing the same thing, as whether you do it as a proportion or as an equation. And then that way, when we actually have real world problems, you'll be able to set them up easily as well. So again, I want you to do these last 5 problems on your own. As always, if you have any questions, please post them to Edmodo.